Hi everyone, this is Julia. I'm going to be walking through week 9's lab slides, which are going to be about object-oriented programming. So last week we talked about abstract data types, or ADTs as we call them, and the idea behind those is going to be very similar to the idea behind object-oriented programming, as you'll see later, but the syntax and the format is going to be a little bit different. Those are going to be things that we've never seen before in this class, but the concepts behind them is going to be really similar. Okay, so without further ado, let's jump right into it. So the first thing we're going to talk about is the intuition behind object-oriented programming. So why even have OOP in the first place? Well, the idea is that we would like to group things together for organization and also to reuse our work or code constantly. So this is the exact same reason why we have functions in programming, because we want to have one thing that we can repeat many times instead of writing those 8 lines of code over and over again. We can just call the function and boom, the 8 lines are called for us automatically. So we are going to use the style of programming called object-oriented programming to group things into a class and apply similar code to everything in that class, or all the objects in that class, as we'll call them. So moving on, a little bit more about the connection between OOP and abstract data types. So last week we talked about some ADTs, such as the city ADT and the dice ADT, as we saw in the assignments last week. And OOP is really similar to these ADTs, or abstract data types. And so we're going to use code to represent a type of object, also known as a city or a dice, and the code is going to apply to every city and dice in that space. So the idea is really similar here with OOP, because we're going to create different instances of the same class. So moving on with our example, we could have a car class and then many instances of that car class. So as we had many instances of a city, we had like a Berkeley city, we could have a Stanford city, and so on and so forth. Here we can have, a Tesla car, a Ford car, a Honda car, and so on and so forth. So the idea is that I want to represent a car in code and make tons of these different cars. And the way we can do that is use a car class. So here is an entire example of a class and how it represents a car. So a class is a recipe for how to build an object. So this code over here on the left is basically an outline for what an object is going to look like when it follows this class recipe. So everything here is going to apply to an instance of a car, of the car class. So each car is going to have, num wheels. It's going to have this function, and this function. So in this case, a car has wheels and color, which we call its attributes. So attributes is just a fancy name for variables that belong to a class. So here we have the num wheels attributes, and remember this is just a variable. And then we also have the self wheels, or the wheels attribute, and self.color. So we're going to talk about the difference between this one over here and this one over here. But for now, you can know that this one is the class attribute, whereas this one is the instance attribute. But before we start talking about that, it doesn't really make too much sense. So we're going to look more deeply into it later on. So the init function over here, let me just erase this drawing. So this init function is going to be our constructor. So as we saw last week, we had a make city function that behaved like the constructor for a city. So in order to make a new city, we had to call that function, and that's why it was called a constructor. And in this case, the init function is always going to be the constructor for any object. and each class is going to have its own init. Sometimes you might see that a class doesn't have an init, but it's kind of like the same thing as having an init method with no code in it. So it's like an init method that's doing nothing, basically. So this init method is a constructor, and then when you call this init method, it's going to create a car object. And for the rest of the functions in the car class, they're all called methods. The init function is called a method, but basically we give them this name because we're talking about functions specifically in the context of a class. So whenever you're talking about classes, the functions are actually called methods, because they are functions that operate on an object. Okay, moving on. So step by step, how to declare a class. You're going to have these three things. So first, the keyword class, and this is kind of like DEF when you're declaring a function. So you put this at the start of the class declaration, and then you're going to have the class name. In this case, we have the car as the class name, and or the word car as a class name, and this part over here, we're going to be talking about this a lot more in depth later on, but basically it's going to symbolize inheritance of this class. So when you put a class name here, it basically says that car is going to inherit from that class. So we could say, let's say there's a class that's called vehicle. So if we put vehicle over here, we could basically have car inherit the code from the vehicle class. But for now, we're just not going to deal with inheritance. But basically here we're saying object instead of vehicle because every single class inherits from this virtual or this universal class called object in Python. So every class is an object, or every class makes an object, and basically it doesn't really mean too much. It's just saying that it doesn't inherit from any other class. It's inheriting from the universal class object. So because it doesn't really mean too much, you can also leave this empty and it would also be correct. So could be empty too. Okay. So moving on to class attributes. So earlier I mentioned the difference between num_wheels and self.wheels, and this is going to be one part of that coin. So num_wheels is going to be a class attribute, and the reason why it's a class attribute is because it doesn't have any self before it. So it's just num_wheels equals 4. So this is a class attribute, and it's a variable that belongs to the whole class. So every single instance of the class is going to have this variable. And moving on to the constructor. So this init method is going to be the constructor for any class. And you'll notice that it says special function name because it's always called this. But one thing I like to point out is that whenever you see these underscores before and after the name, this usually means that we're talking about a magic method. So in Python, there are very special methods. And basically they have some very important roles when it comes to classes. So you'll see the repr method and the stir method, and they have 2 underscores before and after. And whenever you see that, you can always know that, oh, this is a magic method, it probably does something very important. But beyond the name, the constructor usually is what sets up the instance. So you're going to pass in parameters to the constructor. In this case, we have self and color, and self is not really an explicit parameter here. Self is always going to be passed in as like implicitly through the constructor, so you're not actually going to pass in any value for it. Really, you're just going to be passing in color because self is really meant to say, hey, we're talking about a specific instance here, and we're going to be talking about that self keyword a little bit later on in the slides. But know that it's rarely ever passed in explicitly. and color is really the one that's going to be passed into the constructor here. So later on when we say self.wheels, we're saying the wheels of this very specific instance is going to be set to car.numWheels, which we know is 4 from the previous slide. And self.color is going to be that color that we passed in. So that allows every single car to have its own unique color if we want. And it's not like all the cars must have this color that it's applied to the whole class. No, in this case, each instance can have its own color. Okay, and that's what we mean by variables. Can't talk today. Variables that belong to a specific instance. Okay. So making an instance, we're going to call the init method implicitly. And what that means is that we're actually not going to call the method itself. We're going to call the class name and then pass in the parameters. So blue here is going to mean that color that we were talking about. And so we're not actually going to be saying something like init blue. Oops. Because when you call the class name itself and then pass in the parameters, this is exactly like saying init blue, or this over here. It's going to call the init method implicitly and create that instance for you. Okay, and notice that it has the name for the instance, which is Honda, and that's how we refer to it later. It calls the class name and inputs a color. So there was no self here. And the reason for that is because when you're making a new instance, that instance is going to be referred to as self. So self just means like, it's always going to refer to a specific instance. And that is what this point is talking about over here. So when we make this Honda object, it's going to set self.wheels to be 4 and color to be blue. Okay, so these are the attributes that we have for Honda. And then talking a little bit more about the self keyword, it's used to refer to a specific instance of a class. So we always use it in context. And when we're looking at like a specific car, a specific, I don't know, city or dice or what have you. And in this example, we're talking about the Honda when we're talking about self. So whenever you're working with an instance, when you apply functions or methods on it or access its attributes, self always refers to that instance that you're dealing with. And in this case, it was Honda. Okay, and then moving on to dot notation. So a little bit more syntax. Dot notation basically is what we use to access the information in the instance. So when we want to grab those values of the attributes, for example, the wheels or the color, we're going to do the instance name and then dot the attribute name. And so with our Honda example, we might say Honda dot wheels. This gives you 4. And then Honda dot color should give you blue. Okay, so the dot notation is just some syntax that allows you to grab information from the instance, basically access the attribute fields.